Bismillah Rahmanir Rahim. Assalamu alaikum students. Welcome to Physics C1 class. In week 1, we have started the chapter Physical Quantities, Units and Measurement. We will going to continue this chapter. The subtopics of this chapter which will be discussed today are base and derived quantities, SI units, standard form, conversion of units, measurement of length and measurement of time. So objectives of current lesson are by the end of the lesson students will be able to recognize and use the conventions and symbols contained in science symbols and systematics association for science education 2000. Describe how to use a variety of lengths with accuracy using tapes, rules, micrometers and calipers. Describe how to measure a variety of time intervals using clocks and stopwatches. Before starting the base quantities, we are going to revise physical quantities. Any quantity which can be measured is said to be a physical quantity. For example, length, mass, time, and they are described by magnitude and unit. Physical quantities are divided into two major types, base quantities and derived quantities. Base quantities are the quantities on the basis of which other quantities are expressed. And there are 7 base quantities. Examples are length, mass, time, temperature, intensity of light, and amount of substance. Derived quantities are the quantities which are expressed in terms of base quantities. Basically, they are derived from base quantities. And the examples are, some of the examples are area, volume, speed, force, work, energy, power, and electric charge. SI units stand for International System of Unit. What is a unit? In order to measure any quantity, in order to express a physical quantity, we need to specify a standard quantity, and that standard quantity is said to be a unit. Why we need SI unit? Actually, in the past, people used parts of their bodies and the things around them as units of measurement. That was, they were using terms like foot, yard, horsepower, which created confusion. So the scientists in 1960 they decided to adopt one universal set of units said to be SI unit. There are 7 base quantities and their units are said to be the base units, and the unit of derived quantities are said to be derived units. So the SI unit of length is meter, represented by symbol small m. SI unit of mass is kilogram, represented by the symbol small k and small g. SI unit of temperature is Kelvin, and it is given by capital K. SI unit of time is second. It is represented by a symbol small s. Amount of substance is measured in unit mole, and it is given by the symbol MOL. SI unit of electric current is ampere, given by the symbol capital A. SI unit of intensity of light is candela, given by the symbol small c and small d. Derived units are the units of derived quantities. There are few derived quantities given: volume, force, pressure, energy. SI unit of volume is meter cube and it is equivalent to liter. SI unit of force is Newton, given by capital N. SI unit of pressure is Pascal and it is represented by the symbol capital P small a. SI unit of energy is Joule and it is represented by the symbol J. Prefixes, they are basically the words or the terms or letters added before SI units. They are basically the terms used internationally for multiples and submultiples. Multiples are tens having positive power and submultiples are tens having negative power. And the term used for the submultiple 10 to the power 9 is giga, for 10 to the power 6 it is mega, for 10 to the power 3 it is kilo, and for the submultiple 10 to the power minus 3 it is milli, 10 to the power minus 6 is micro, 10 to the power minus 9 is nano, and 10 to the power minus 12 is pico. Next, we have to discuss how to write a number in standard form or in scientific notation. Scientific notation, it is a method in which a number is expressed as power of 10 multiplied by a number between 1 and 10. Next, we have to discuss the rules to write a number in scientific notation. The first rule is that there should be a non-zero digit before the decimal point. The second rule is that if the number is too large, in that case, non-zero digit will be multiplied by a multiple. And if a number is very small, then the non-zero digit will be multiplied by a sub-multiple. For example, in part A very large number is given. In order to write it in standard form, first we need to add a decimal point to it. We have added the decimal point at the end of the reading. You can see that it is 2,460,000.0. Then now we have to shift the decimal point on the left side of the decimal point, and we have to see it is shifted to how many places? 1, 2, 3, 4, 5, 6. It has been shifted to 6 places. So it will be multiplied by a multiple. Whenever the decimal point is shifted on the left side, the non-zero digit is multiplied by a multiple. So over here, the non-zero digit is 2. It will be multiplied by a multiple, and the power of 10 depends upon the number of places to which the decimal point have been shifted. So it has been shifted to 6 places, so the power of multiple will be 6, and the final answer will be 2.5 into 10 power 6 centimeter. We have rounded off 4 because there was 6 before, after 4. So whenever there is 5 or a number greater than 5, then 1 is added to the previous number. So previous digit is 4. To 4, 1 is added, so the final answer becomes 2.5 into 10 to the power 6 centimeter. Now the second case, when the number is very small, over here non-zero digit is 1. So over here the decimal point is to be shifted on the right side of to the right side, and we have to see it is shifted how many places. So it is shifted to 8 places. So the final answer will be 1 into 10 to the power minus 8 meter. So whenever the decimal point is shifted to the right side, the non-zero digit will be multiplied by a sub-multiple. Over here, the non-zero digit is 1, and it is being multiplied by a sub-multiple, and that is 10 to the power minus 8. The power of the sub-multiple depends upon the number of places to which the decimal point have been shifted. Next topic is conversion of units. First, we are going to see what are different units used for the measurement of length. SI unit used for the measurement of length is meter. Other units are kilometer, meter, centimeter, millimeter. So we have to see what is the relationship between them. 1 kilometer is equivalent to 10 to the power 3 meter, that is 1000 meter. 1 meter is equivalent to 100 centimeter or 10 to the power 2 centimeter. 1 centimeter is equivalent to 10 millimeter. 1 meter square is equal to 10 to the power 4 centimeter square. How we have derived this relation? Actually, meter square is the unit of area. So in order to derive it, this relation has been squared. Square of 1 is 1, square of meter is meter square, square of 10 to the power 2 is 10 to the power 4, square of centimeter is centimeter square. SI unit for volume is meter cube. So how this relation has been derived? For this, again, this relation has been cubing this relation. 1 cube of 1 is 1, cube of meter become meter cube, cube of 10 to the power 2 is 10 to the power 6, and cube of centimeter is become centimeter cube. Now over here the opposite relations are written. In 1 meter there are 10 to the power minus 3 kilometer, that is, it is being divided by 1000. In 1 centimeter there are 10 power minus 2 meter. In 1 millimeter there are 10 power minus 1 centimeter, that is 1 by 10 of centimeter. In 1 centimeter square there are 10 power minus 4 meter square, and in 1 meter cube there are 10 power minus 6 meter cube. Now we have to discuss some examples of conversion of unit. For example, we have to convert 3 kilometer to meter. 3 kilometer in the next step will be replaced by its equivalent relation in meter. 1 kilometer is equal to 10 power 3 meter. So in the next step, instead of kilometer, what will be written? 10 power 3 meter. So the final answer become in standard form 3.0 into 10 to the power 3 meter. The next question is that converts 60 meter square to centimeter square. So 60 meter square in the next step, meter square will be replaced by its equivalent value, and its equivalent relation is 1 meter square is equal to 10 to the power 4 centimeter square. So in the next step, instead of meter square, we have written 10 to the power 4 centimeter square. So the final answer becomes 6.0 into 10 power 5 centimeter square. How it become 5? There is one zero of 60 and there are four zero of 10. So combining them, 4 plus 1 becomes 5. The next question is convert 4000 centimeter to meter. So we have 4000 centimeter. In the next step, instead of centimeter, we're going to write its equivalent relation. Centimeter will be replaced by 1 centimeter is equal to 10 power minus 2 meter. So it will be replaced by 10 power minus 2 meter. In the next step, 4000 is written as 4 into 10 power 3, and centimeter had been replaced by its equivalent relation 10 to the power minus 2 meter. So the total power of 10 now becomes 3 minus 2 is 1. Final answer is 4.0 into 10 meter. Next question, convert 800 centimeter cube to meter cube. Over here, centimeter cube in the next step will be replaced by its equivalent relation. And what is the equivalent relation? 1 centimeter cube is equal to 10 power minus 6 meter cube. So it becomes 800 into 10 power minus 6 meter cube. Now 800 can be written as 8.0 into 10 to the power 2, and centimeter cube has been replaced by 10 to the power minus 6 meter cube. Total power of 10 become minus 4. Minus 6 plus 2 become minus 4. So the final answer is 8.0 into 10 to the power minus 4 meter cube. Next we have to discuss the units of mass. SI unit of mass is kilogram. In 1 kilogram there are 1000 gram or 10 to the power 3 gram. In 1 gram there are 10 power 3 milligram or 1000 milligram. In 1 gram there are 10 power minus 3 kilogram, and in 1 milligram there are 10 power minus 3 gram. In order to convert smaller unit to bigger unit, we need to divide, and in order to convert a bigger unit to smaller unit, we are going to multiply. Now we have to discuss the units used for the measurement of time. SI unit used to measure time is second. Other units are hours, minutes. So in 1 hour there are 60 minutes, in 1 minute there are 60 seconds, in 1 hour there are 3600 seconds. In 1 minute there are 1 by 60 hour, in 1 second there are 1 by 60 minutes, in 1 second there are 1 by 3600 hours. Now we have to see the example in which we have to convert two units at the same time. For example, convert 30 kilometer per hour to meter per second. So we have to do the conversion of two units at the same time. One is kilometer and that has to be converted into meter, and other is hour and it has to be converted into second. So 3 kilometer per hour can be written as 30 kilometer over hour. In the next step, kilometer will be replaced by its equivalent value in meter, and 1 kilometer is equivalent to 10 power 3 meter. It has been replaced in the next step, and 1 hour will be replaced by its equivalent relation in second. 1 hour is equivalent to 3600 seconds. So in the next step, hour will be not written. Instead, what will be written? 3600 seconds. After simplification, the final answer is 8.3 meter per second. Next question, convert 20,000 Newton per centimeter square to Newton per meter square. So Newton is not to be converted. Centimeter square is to be converted to meter square. So 20,000 Newton over centimeter square, it will be written like this, and then in the next step centimeter square will be replaced by its equivalent value in meter square, and that is 10 power minus 4 meter square. On simplification, the answer is 2 into 10 power 8 Newton per meter square. The next question is convert 4000 gram per cubic centimeter to kg per meter cube. So 4000 gram per centimeter cube can be written like 4000 gram over centimeter cube. So gram will be replaced by kg and centimeter cube will be replaced by meter square by their equivalent values. 1 gram is equivalent to 10 power minus 3 kg. So in the next step, gram will not be written. Instead, what will be written? 10 to the power minus 3 kg. And in the next step, centimeter cube will not be written. Instead, what will be written? 10 to the power minus 6 meter cube. And 4000 in the next step can be written as 4 into 10 power 3. So 3 minus 3 becomes 0. We have minus 6, so it becomes, final answer becomes 4 into 10 power 6 kg per meter cube. Next, we have to discuss measurement of length. SI unit of length is meter. How to define length? It is basically the distance between 2 points. Different instruments are used for the measurement of length. For example, meter rule, measuring tape. Meter rule is used to measure length up to 1 meter. So if we want to measure a length greater than 1 meter, then measuring tape is used. Measuring tape is made up of flexible material, so it can be bent, and it can be also used to find the length of curved object. Example, circumference of a football can be measured using measuring tape. It can also be used to measure the depth or the width of a pond. Next, we have to discuss the precision value of meter rule and measuring tape. Precision value is the smallest unit which can be measured by using an instrument. So both measuring tape and meter rule, they have same precision value, and that is 1 millimeter or 0.1 centimeter. Next, we have to discuss the error which arises in the measurement when we are taking a reading using a meter rule. That error is said to be parallax error. How to define parallax error? It is the error in the measurement due to wrong position of the eye. So we have to see what is the correct position of the eye to get an accurate measurement. Eyesight should be perpendicular to the scale. Eyesight should be perpendicular to the scale means that it should be making an angle of 90 degree with the scale, and it should be directly above the division which is to be read. This is the wrong position of the eye, because over here eyesight is not making an angle of 90 degree with the scale. So this is the correct position. Next, we have to discuss the use of calipers. It is an instrument used to measure the diameter of cylinders or circular objects. The jaws of the calipers, they are used to grip the widest part of the object. When the object is removed, the distance between the jaws can be measured using meter rule. There are 3 types of caliper. Inside caliper is the first type, and it is used to measure the internal size, internal diameter of an object. This is a diagram of internal calipers. Inside caliper. The second type is the outside caliper. They are used to measure external diameter or external size of an object. The third type is the divider caliper. Divider caliper is used to measure a distance between 2 points on a map. Next, we have to discuss micrometer. When we want to measure a length smaller than 2 centimeter, then we are going to use micrometer. It measures the length of an object up to an accuracy of 0.01 millimeter or 0.001 centimeter. This is a micrometer. We have to see how to take a reading using a micrometer. For example, this is the object, this yellow is the object, and it is placed between anvil and spindle. Then we have to read the two scale. There are two scale. This one is the main scale and this one is the thimble scale. Main scale, it has a horizontal line. This line is also said to be the datum line. And this is a thimble scale or a circular scale. So the length of this object will be equivalent to the sum of the reading on main scale plus the sum of the reading on circular scale. How to note the main scale reading? For that we have to see which division is just before the edge of the circular scale, and it is 2.5. The smaller division on the main scale represent 0.5, and the longer divisions, they represent 1 millimeter reading. So before the edge of the circular scale, this is the division which we can see. So it is 2. So we can also see a smaller division. So the answer becomes 2.5 millimeter. And then we have to see what is the division on the circular scale, which division of circular scale is in coinciding with the datum line, which division of the circular scale is exactly in line with the datum line, and its number is 33. We're going to start counting from 30 and it is 33. 33 will be multiplied by the least count of micrometer. Least count is the smallest unit which can be measured using micrometer, and it is 0.01 millimeter. So the number of division of circular scale or the thimble scale which is in line with the datum line, it will be multiplied with the least count, and that is 0.01 millimeter. So it becomes 0.33 millimeter. So how to get the length of this object? It is equivalent to the sum of main scale reading and circular scale reading. So adding them, the answer becomes 2.83 millimeter. Next, we have to discuss the error find in micrometer. How to check an error in the micrometer? For that, we need to close the micrometer so that there is no gap between the anvil and spindle. They are in contact with each other. Then we have to observe the position of zero on thimble scale. The first diagram show that there is no zero error in the micrometer. We can see that the zero of the thimble scale, it is in line with the datum line of the main scale. Then there is no zero error. In order to check the zero error, we need to close the micrometer so that there is no gap between the anvil and the spindle. They are in contact with each other. Okay, now if the zero of the thimble scale it is not in line with the datum line, then either it will be below the datum line or it will be above. If the zero of the thimble scale is below the datum line, then the error is said to be positive zero error, and if the zero is above the datum line, it is said to be the negative zero error. How to calculate the value of positive zero error and negative zero error? Simply we have to see which division is coinciding with the datum line. If it is not zero, then which division is coinciding? Over here we have to start counting from zero, and it is the second division which is coinciding with the datum line of the main scale. So that division will be multiplied with the least count of micrometer, which is 0.01 millimeter. So 2 multiplied by 0.01 millimeter become 0.02 millimeter. Now, how to get the corrected reading? In case of positive zero error, it will be subtracted from the observed reading. The observed reading was 2.83. So 0.02 will be subtracted from it to get the accurate reading. So the answer becomes 2.81 millimeter. Now we have to see how to calculate the value of negative zero error. For that, we have to see which division of the thimble scale is in line with the datum line of main scale. We have to start counting from zero, and it is the fourth division which is coinciding with the datum line. The fourth number will be multiplied with the least count 0.01, and it becomes 0.04 millimeter. It will be a sign negative sign because it is a negative zero error. And how to get the corrected reading? What we have to do, we have to add the negative zero error to the observed reading. Observed reading was 2.83 plus 0.04. So answer become 2.87 millimeter. So positive zero error is subtracted from the observed reading to get the corrected reading, and the negative zero error is added to get the accurate reading. Next, we have to discuss another type of micrometer, that is the digital micrometer. It gives a more accurate value because over here we don't need to see the position of main scale and thimble scale. We don't have to note the reading from the main scale and thimble scale. Over here the reading is shown on the dial of the micrometer. Now what are the advantages of using digital micrometer? The first one is that it is easier to use because we don't have to observe the main scale reading and circular scale reading. It reduces the operator error and it can be used quickly. It gives a more precise value. Disadvantages: it run on a battery or a cell, and so it is expensive. Next, we have to discuss measurement of time. To measure time, stopwatches are used. There are two types of stopwatches: mechanical stopwatch and digital stopwatches. Mechanical stopwatch, it measures time up to an accuracy of zero point 0.1 second, whereas digital stopwatch, they measure time up to an accuracy of 0.01 second. In case of mechanical stopwatch, we have to observe the position of the hand to find out the reading. Over here, the reading is displayed on the dial of the digital stopwatch, so it is more accurate. Now, when we are using any stopwatch, we have to press the button to start the stopwatch and to stop the stopwatch. So this manual operation introduces a random error, and that error is said to be human reaction time. Its value is between from 0.3 to 0.5 second. The next topic is simple pendulum, and we have to see how to find the time period of simple pendulum. What is a pendulum? It consists of a string, and string is attached to a metal bob. The length of pendulum is marked from the point of support till the center of the bob. So this L is the length of pendulum from the point of suspension till the center of the bob. Point O over here shows the rest position, the mean position. Point A and B, they are the extreme position. So in order to find the time period, the bob is taken from O to A. So when bob is taken from position O to A and it is released, it is observed that it moves from point A to O, from B back to A, right? So we have to discuss when a bob is said to complete one oscillation. When the bob moves from point A and it comes back to the same point A, then it is said to complete one oscillation or one vibration. Actually, oscillation or vibration is to and fro motion. So a pendulum is said to complete one oscillation or vibration when it moves from one extreme position and returns back to the same extreme position. Next, we have to discuss what is time period. Time period is the time taken by the bob to complete one oscillation. It is the time taken by the bob to complete one vibration. How to calculate the time period? For that, first we need to measure the time using a stopwatch taken by the bob for a certain number of oscillations. For example, 10 oscillations. We are measuring the time using a stopwatch required by the bob to complete 10 oscillations. After that, we're going to repeat this process for the same number of oscillations, and we will get two readings and we're going to calculate the average of the two readings, and then the average time will be divided by number of oscillations. So what we have to do, we have to measure the time, for example, for 10 oscillation, and then we have to again measure the time for 10 oscillation. We have to repeat that process, and then we have to calculate average. Average time is divided by number of oscillation to calculate the time period. How to calculate frequency? Frequency is basically the number of oscillation or vibration made by the bob in 1 second. It is what number of oscillation vibrations made by the bob in 1 second, and its formula is small f is equal to 1 over t. So frequency and time period, they are inversely proportional to each other. Next, we have to discuss what is amplitude. Amplitude is a horizontal distance from the rest position or to one of the extreme position. That is, the distance from O to A, or the horizontal distance from O to B is the amplitude. The next topic is graphs, dependence of time period. The time period depends upon the length of the pendulum. If a graph is plotted between time period and length, the shape of the graph is curved. If the graph is plotted between square of time period and length, then it is a straight line. So time period depends only on the length of the pendulum. The time period does not depend upon the mass of the bob or the amplitude of vibration. So if we are doing the experiment by using bobs of different masses, there will be no effect on the value of time period. Or if we are changing the amplitude of the bob, there will be again no effect on the value of time period, and the shape of the graph will be a horizontal line. If the time period of the bob is 2, throughout it remains 2, whatever is the mass of the bob. If it is 1, then again the time period is 2. If it is 15, again the time period is 2. If it is 25, again the time period is 2. Over here, we can see that again the time period is 2 for different values of amplitude. At 5 it is 2, at 15 it is 2, at 25 it is 2. So time period depends upon length, but it is independent of mass and amplitude. It means that changing mass or changing amplitude will not going to change the value of time period, it remain constant. The next topic is ticker tape timer. It is used to measure time. It measures time up to an accuracy of 0.02 seconds. This diagram shows the structure of ticker tape timer. It consists of an electric motor. A metal bar is attached to the electric motor. Below the vibrating bar, there is a carbon disc. Below the carbon disc is passing white ticker tape. This white ticker tape is connected to a moving object. So when the object is moving, the tape is also moving below the carbon disc. How it works: when the electric motor is switched on, when the ticker tape timer is switched on, this metal bar starts to vibrate. It vibrates 50 times in 1 second because the frequency of the current supplied to the electric motor is 50 hertz. So it vibrates 50 times in 1 second. Actually, what happens when the strip moves downward? It causes the carbon paper disc to come in contact with the white tape. So when the carbon disc come in contact with the white tape, a black dot is marked on the white tape. So 50 dots are marked in 1 second on the white tape. Next, we have to see how to calculate time using ticker tape timer by the dot pattern formed on the white tape. This is the dot pattern shown. If we are asked to calculate the time interval between these two vertical lines, for that what we have to see, there are how many consecutive pair of dots present between these two vertical lines, and they will be multiplied by 0.02 second or by 1 by 50th second. So there are 7 dots present, 7 consecutive dots present between these two vertical lines. 7 pairs of dots are present between these two vertical lines. 1, 2, 3, 4, 5, 6, 7. This 7 will be multiplied by 0.02. So answer becomes 0.14 second. Ticker tape timer can be used to find velocity or the speed of the body. The formula for speed or velocity is distance over time. For distance, we're going to measure the distance between these two vertical lines by using scale. For example, it is 7 centimeter. So distance will be replaced by 7 centimeter, and the time interval measured between these two vertical line was 0.14 seconds. So it will be written over here in place of time. So the final answer is 50 centimeter per second. Okay, in the last, we're going to do the recap. Physical quantities, they are divided into two types: base quantities and derived quantities. There are seven base quantities: length, time, mass, temperature, electric current, amount of substance, and intensity of light. SI unit of length is meter, time second, mass kilogram, temperature Kelvin, electric current ampere, amount of substance mole, intensity of light candela. So time is one of the base quantity, length is one of the base quantity, SI unit of length is meter. Instrument used for measurement of length are measuring tape. It measures length up to an accuracy of 0.1 centimeter, and it is used to measure lengths greater than 1 meter. Meter rule measures up to an accuracy of 0.1 centimeter. It is used to measure length between several centimeter to 1 meter. Vernier caliper, they measure length up to an accuracy of 0.01 centimeter. So it is suitable for lengths between 1 centimeter to 10 centimeter. Micrometer measure a length up to an accuracy of 0.01 millimeter, and it is suitable for lengths less than 2 centimeter. SI unit for time is second, and we can measure time by using clock, by using stopwatch, by using pendulum. How to find the time period of pendulum? We need to find average time taken by 10 oscillation, and then that is divided by number of oscillation. So general formula for time period is time taken for a certain number of oscillation over total number of oscillations. In all these devices, time is measured by using repetitive motion. For example, in clocks and stopwatches, vibrations of crystals are used to measure the time. And in case of pendulum, the swings of the bob, they are used to measure the time period. The repetitive motion of the bob, the to and fro motion of the bob is used to measure the time period.